Okay, so how does fluid move out and in into from the capillaries into the interstitial fluid and from the interstitial fluid into the capillaries? Okay, so the movement of things in and out of the capillaries. Okay, in and out of the capillaries and also in and out of the tissues. All right, let's review this. First of all, understand that there is the arterial end. This is the venule end. Okay, and this is the capillary. I'm gonna put capillary here. This is the capillary. The whole thing is the capillary. Okay, now we talked about how capillaries are places of exchange. So what's going to happen? Well, we're going to be dropping off oxygen. We're going to be dropping off amino acids, which are nutrients. We're dropping off glucose, and those are the good stuff, right? But also, cardiovascular system also picks up the waste, right? So we're going to be picking up carbon dioxide. So carbon dioxide goes from the tissues into the blood, and waste are also going to come from the tissue cells into the blood. Okay, and we're going to take those to get rid of those later on. Okay, now let's read through this, and I'll explain. So the heart creates something called blood pressure. Okay, which is the pressure, the force of the blood traveling in the veins. Okay, blood pressure acts to move water out of the capillary. Okay, but the thing is that you're going to have two forces here. You're going to have something called blood pressure, and you're going to have something called osmotic pressure, and they're also here. Okay, so what happens here is there's an interplay. Okay, there's an interplay between two forces, two opposite forces. Think of it like this: blood pressure. Think of the blood pressure BP as pushing out, and the one and osmotic pressure as pulling in. Okay, so you have those two pressures, those two forces throughout your capillary. Okay, you have it all over here, all over here. Okay, you have all those two forces happening. What's going to happen is things are going to be moving in and out depending on who's going to win. If the blood pressure wins, if the blood pressure is higher than the osmotic pressure, then blood pressure is going to win. If osmotic pressure is higher than blood pressure, then osmotic pressure is going to win. Does that make sense? So if you push harder than what someone is pulling in, you're going to be pushing out, right? If you push and not as hard as someone pulling in, then the thing is going to come inside. Does that make sense? Hope it does. Now, osmotic pressure, just so you know, and it says here, is created by the presence of proteins in the blood, which are these green things over here. Okay, these are proteins. And if you think about osmotic pressure and you start thinking that sounds exactly like osmosis, that is absolutely true. That's why I showed you osmosis in the beginning. What is osmosis? Okay, the diffusion of water. Water diffuses from an area of low solute concentration, which would be outside, to an area of high solute concentration, which would be inside. Or we can say, same thing, water travels from an area of high water concentration, which is outside, to an area there is low water concentration, which is inside. Okay, so far so good. Okay, so that's why osmotic pressure is that pressure because of the proteins in the blood, and acts to move water into the capillary. Think of it as pulling in, or think of it as sucking in. Okay. Now, blood pressure is going to be higher than osmotic pressure at the arterial end. Okay. So here, let me actually erase a couple of things here, if I can, just because I don't want to make this so illegible. Okay. Maybe that's it. Okay, good deal. So what happens here? What happens at this end, at the arterial end? Blood pressure, okay? Blood pressure is going to be higher than osmotic pressure, okay? So blood pressure is going to be higher than osmotic pressure. The capillary, so the water is going to be moving out of the capillary. That's why you have water moving out of the capillary, okay? Again, the push was stronger than the pull. What happens at the venule end of the capillary? Well, blood pressure is going to decrease. And we saw this in the previous, one of the previous slides, right? Blood pressure at the venule end is really going to be low. Okay, so blood pressure lessens as the blood moves through the capillary bed. This means that the osmotic pressure is going to be higher than the blood pressure at the venule end of the capillary. Okay, so here osmotic pressure is going to be greater than blood pressure, which is going to be, remember what osmotic pressure is, it's going to be like a suck in kind of force. So water is going to be going inside, okay, it's going inside the blood, inside the capillary. Okay, in this case here, it's the same thing, it's just I'm going from here. I put a value for water. Water here is still going to go inside. The point is it goes inside of the capillary, into the capillary. Okay. So osmotic pressure is going to be higher at than blood pressure at the venule end of the capillary, and water moves back into the capillary. Simple as that. I hope that made sense.